Today we're going to do a quick demo on some of the problems you'll face when using an external monitor with a Canon DSLR, and also show you SmallHD's exclusive solutions to these issues. Primarily, we'll be talking about effective pixels. This is a pretty important subject, as you always want to get the most resolution and viewing area out of any display. Unfortunately, these cameras don't provide a signal that enables the use of the full screen of any display out of the box. The surprising part is how many pixels are lost in certain instances, so you may not be getting as much out of your monitor as you think. So we'll cover the amount of pixel loss found on a variety of displays as we go through this demo. What we have set up here is a Canon 5D with a SmallHD DP6 sitting on top, and a Canon T2i with a random 4x3 monitor on top of it for comparison purposes. The 5D has a 640 by 480 display, which ends up being 920,000 individual RGB dots as some displays are advertised. If you're unfamiliar with the term dots, it comes from multiplying the horizontal and vertical resolutions together, then multiplying that number by 3 for each red, green, and blue image element. Surprisingly, the resolution of the T2i's display is actually a bit higher at 720 by 480, or 1.04 million dots. Now we can turn these cameras on and have a look at the signals that show up on the back of them. As you can hopefully see, the T2i uses its full screen to display the image from the camera's sensor. That's because the image sensor has a 3:2 aspect ratio, just like the 720 by 480 screen. The 5D, on the other hand, has a 4:3 LCD, which means it has to map the 3:2 shape of the sensor onto this display somehow. To do that, it uses a resolution of 640 by 427 for the image coming from the sensor. It then uses the leftover area at the bottom of the display for camera data, whereas the T2i overlays the data onto the image from the sensor. As you can see, there's no real drama with the display here when jumping from live view to record, and back to live view, and then in and out of playback, where the recorded image is 16:9. Aside from having different LCD resolutions, both of these cameras behave in the same fashion. They also behave in the same fashion regarding their HDMI outputs, and we're about to see that monitoring externally isn't nearly as straightforward as viewing on the camera's LCD. Let's plug the monitor all the way into the 5D here and take a look at the DP6. 1080i up in the corner indicates a 1920 by 1080 HD signal with a 16:9 aspect ratio, but what we're seeing doesn't look anything close to 16:9. Pressing the info button on the 5D 3 times gets rid of the camera data and fills the screen with image a bit more, but we're still not seeing a full screen width view. Let's try this with the T2i and our second monitor here. The same initial look comes up, so we'll get rid of the T2i's camera data by pressing the display button 2 times. Even still, there seems to be an even larger black border around the image on this 4:3 monitor. There's a relatively simple explanation for these annoying black borders, and it's the same for all monitors. First off, the DP6 has a 16:10 aspect ratio, and the other monitor is 4:3 as labeled, both taller than the 16:9 HD aspect ratio that is coming from the camera. Any monitor like these two that are not native 16:9 resolutions will add this black letterbox to the top and bottom as it scales the 16:9 signal to fit the screen appropriately. These top and bottom borders will not show up on a native 16:9 TV or monitor. What will always show up are the black borders on the left and right. This pillar box effect is actually embedded into the signal from the camera. The image we're seeing on the screen is the same shape as the camera sensor, which, as we said before, is 3:2. For this 3:2 shape to be sent to a monitor using a 16:9 HD signal, the camera adds this pillar box to the left and right, and as a result, the monitor thinks the image is filling the full width of the display. In other words, the resolution of the signal from the camera is 1920 by 1080, which is 1080i, but the resolution of the image we actually see is only 1620 by 1080, a 3:2 shape within the 1080i signal. As you've guessed, this is wasting a lot of screen size and resolution. To be exact, it's wasting 15.6% of just the screen's width. That goes for any monitor or TV. In the case of the DP6, it's only using 1080 by 720 of its full 1280 by 800 resolution, meaning a 24.1% loss of screen area and resolution when combining the pillar box and letterbox. It's even worse with the 4:3 monitor. Its normal 1024 by 768 resolution is now down to only 864 by 576, a massive 36.7% loss in screen area and resolution. In fact, the image diagonal seen here is only 5.25 inches. That's an inch and a quarter lower than its full 6.5 inch diagonal. As you can see from this overlay, the image on the DP6 is relatively proportional to the size of the second monitor, as the DP6 only has a 5.6 inch diagonal. At this point, the only way to get a full screen width view of this Canon DSLR signal is if your monitor or TV has some type of zoom function. Fortunately, the DP6 has a very precise zoom function called Custom Scale. As part of our version 1.1 firmware release, we actually dialed in this function to perfectly reproduce this DSLR signal at full screen width for DP6 users, and created a preset for it called DSLR Record for use in live view and record modes on these Canon DSLRs. Now the DP6 is using its full screen area and 1280 by 800 resolution to show the 1620 by 1080 image coming from the camera's sensor. If we look at another overlay, you can see how much bigger this new image is than even what's on the larger 4x3 monitor. It's important to remember that this zooming effect doesn't downgrade the video quality. In fact, it actually improves it. The 1620 by 1080 image from the sensor is simply showing up on 1280 by 800 pixels rather than the original 1080 by 720, so you'll see more detail as a result. Another major issue that this DSLR Record preset solves is regarding the resolution and aspect ratio change that happens when the record button is pressed on these two cameras. Let's take a look at what happens when the record button is pressed while these monitors are on their normal settings. As you can see, the image on the DP6 just sort of squishes flat a bit. The same thing happens to our second monitor here. This is because the cameras are now sending a 480p SD signal with a 4:3 aspect ratio. The scale setting on each monitor must be changed to 4:3 to correct the squishing issue. Several monitors on the market, including the DP6, have an auto scale setting to help avoid pressing buttons like this when you start and stop recording. But that doesn't get around the fact that even in this SD mode, there's still a big black border around the whole image. Now we'll stop recording and show you how the DP6's DSLR preset compensates for this issue. We'll simply hop back into the DSLR Record preset and try it again. Here's the DP6 in action during live view, and now during record mode. You may or may not be able to see it down-res from where you're sitting, but the image itself doesn't move at all. On other cameras, like the 1D Mark IV and the 7D, this isn't an issue. The resolution remains the same as it is here in live view mode, which is obviously ideal. As far as we're aware, this is the one and only true fix for these issues, and it's only found on the DP6. So, to sum up, when viewing signals from Canon DSLRs via HDMI, there aren't going to be as many active pixels on your display as you'd hope. A 4:3 monitor will not use 36.7% of its pixels. A 16:10 monitor like the DP6 will not use 24.1%. Unless you have the DP6 and firmware version 1.1 or later, which can be downloaded for free off of our website. A 15:9 monitor, like our old DP1 or a monitor with an 800:480 resolution, will not use 20.1% of its screen. In fact, an 800:480 display will only use a resolution of 675:450 for image. That's actually slightly less than the 720:480 resolution on the back of the T2i, and only slightly more than the 640:427 pixels used on the back of the 5D, 7D, and 1D. And finally, a native 16:9 monitor loses 15.6% as it only loses pixels on the sides. This all just goes to show that you might not be getting use out of all the pixels you're paying for. Anyways, we hope this was educational. We'll be back with more on pixels at a later date. If this video wasn't nerdy enough for you already, feel free to read the blog article posted below. Thanks for watching.